not something you can like put there and
I
then
keep
leave it
on
for
going.
like 7 days. You have to watch it
All the
constantly.
time, yeah. Okay, recording is started again. We're done with the slide. Going to the next one.
I have stock in cold.
Okay, we're going to talk about the number E.
Say that one more time.
The number E.
Okay.
Okay.
He is a letter.
Okay. We're going to talk about the number E. Pi is a number, correct?
Yeah.
Pi is approximately
3.14.
great. Pi is a Greek letter that represents approximately, it's the diameter divided by the circumference divided by the diameter. Okay, the circumference of a circle divided by diameter is approximately 3.141592887, blah, 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 blah. Okay, E, just like pi, is an irrational number. Okay, it has a specific value. That value can be obtained by the expression 1 plus 1 divided by n raised to the nth power as n approaches infinity. Which means n never ends, right? It goes on and on and on and on forever and ever. So does this kind of look like what we've been messing with? A equals P times 1 plus R over N raised to the NT power. So it kind of looks familiar to that. Okay? What we're going to do is we are going to take this expression and evaluate this expression with these values of N. Okay? For example, the first one. I want to know what is 1 plus 1 over 1 raised to the first power. I changed the N's to 1's. Not a big deal. Yes.
So E equals 1 plus 1
Just
over.
hang on. Okay? And what is, so I changed the n's to 1's because that's what n is. So I have 1 plus 1 over 1, which is 1. So 1 plus 1, which is 2. And 2 to the first power is? Let everybody answer at once.
Wait, what was the question?
2 to the first power.
2.
Okay. Hard stuff.
Yes.
Okay? Well, what happens is n gets bigger. I now have 1 plus 1 half, because n is now 2, squared. Well, 1 plus a half, that would be 1.5. And 1.5 squared would be 2.25. It got bigger. Does it make sense that it got bigger?
No. Yes.
I'm taking something and raise it to a bigger power. It's getting bigger, right? But what I'm adding to the 1, what's happening to that? This is 1 plus 1. Now I have 1 plus a half. It's getting smaller. So I've got the number 1. I'm adding a smaller number to it, but the power's higher, then the number got bigger. We're now going to do 5. 1 plus 1 over 5 squared. No, to the 5th power. Now I can't, I don't know this one.
No, I'm working on it.
This is 1.2, right? 1 plus 1/5. So we have 1.2 to the 5th power. Is it going to be bigger than 2.25?
Yes.
It will be bigger.
2.48832.
Is that it completely? 2.
48832.
Okay.
Why do you want to go so far into the decimals?
Just hang on. You'll see.
You keep saying that.
Okay. Did it get bigger?
Yes.
Okay.
10.1 to 10.
Okay. I want you to do 10, 100, 1,000, 10,000, 1 million, 10 million. Plug it in. I'm not going to write them all down. Okay?
Ooh, wow, that is a.
So use that equation and change the n to the number I told you to use.
I'm gonna somehow mess up.
I want to do GA, but I'm just curious.
Wait, mine's 10 million, right?
10 million. Okay? Kind what you get for 10.
2.59374246.
It's getting bigger. And what you get for 100?
2.7048138829.
Oh, I put it.
Leilani, 1,000.
2.71692393
2.
Notice it's getting bigger every time, isn't it?
Well, I don't even know which one I'm writing down right now.
Mason, 10,000.
Still doing this. I'm slow.
1 plus 1. 0.
Huh. Go figure.
1 0.
Oh, I see why now.
Equal
Mason, what you get?
I got 1. Which I don't think is correct.
You got one.
Okay, 1 million.
Oh.
Cassie, what'd you get?
2.718280469.
I think that's what you said. 182804669.
That is a fairly
Okay.
close number.
10 million.
2.718281693.
It's getting bigger, isn't it? Every time. How long is it gonna take to get to 3?
It'll never get to 3.
It'll never get to 3. That is the correct answer. Mason, do you have a good number for 10,000 yet?
I'm
2.718.
Hold on.
459.
Hey, 2.7. Go.
181459268
One
That's not what I
eight
got.
one.
That's not what I got.
I got 2.718145927.
Yeah, that's what I got. I'm using the free book
What?
calculator, so it goes a lot longer.
Okay, so you got something. Okay, whatever. That rounds to 7 there, right? Okay.
Oh, yeah, it does.
So it will never get to 3. What it will get closer and closer and closer to is the number E.
What's
Okay,
Infinity.
that's bigger than 3. It's not getting
Easy
bigger than
ass.
3.
I'm almost done. I'm almost done.
Is it? Tell me at least there's someone close.
3. Okay.
Okay, E. Look at this number here. 2.71828
693.
169. Okay, here's E. E is approximately 2.718281828 459.045.
2.7.
Okay, by any chance, you're not gonna have us memorize the whole
No.
digit?
Okay.
Wait, I lost my spot.
Is there something in the
No.
calculator that auto calculates E?
2.7.
Okay, on the calculator, see this button that says LN on it? Right above it is E to the X. If you press second, E to the X, what would be a good exponent to tell you what E was? 1? There it is.
2.7.
Oh, I already got that past that part. So the other one.
1 8.
1828, 1828.
Wait.
1 8 2 8 1 8 2 8
459
4 5 9.
045.
I think it's still wrong. I think I wrote 1 8 2
It
8
doesn't
too
matter.
much.
Mine looks so long.
Okay, so that's the approximate value of E. And if we would have kept going with our ends, bigger than 10 million to 100 million,
Perfect.
at some point, I think the calculator says, I can't do that for you anymore.
I'm on.
Really?
Okay.
I'll try it.
But that's it. Okay, this brings into continuous compounding. This means that money that we invested at 4% that was compounded quarterly, we're now going to invest that money and it's going to be compounded continuously, which means every microsecond, in fact, more frequently than that, it's being compounded again. The compounding does not stop. But remember, I'm taking the number 1 and adding essentially 0 to it. Because that's what's happening, right? Think about that. Let me go back 2 slides, 1 slide, 2 slides. What is 1 plus 1/10 millionth? How small is that?
0. Yes.
Okay, but I'm going to raise that to the 10 millionth power. But it's always going to be bigger than 1. So the formula is the amount after is equal to the amount you started with times E to the RT power, where R is the interest rate and T is the number of years it's being compounded. Years ago, there used to be a shampoo called Pert,
Hurt.
so that's how I remembered this.
So wait, overflow says it's too much.
Yeah, it's fine, you'll get an error, but the number's gonna be that. It's crazy. But
Wait, what does?
once that exponent gets too big, it calculator freaks out.
Wait, what's P?
So will it ever
P is
get?
the amount of money you start with.
Oh.
E is a constant, 2.718281828, yada, 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 yada. To the RT power.
So the highest value using that equation is gonna be E.
Yes. Yeah. Okay, here's a problem. $5,000 is deposited into an account that pays 3% interest, no such bank. Compounded continuously, so the second you see that word right there,
A equals per.
we're using E. Okay? As soon as you see continuously, we're doing E. So we have the amount after is equal to P, the amount we start with, times E to the interest rate times time. How much money do you have after 5 years? So we're looking for the after. I'm starting with $5,000 times E. The interest rate is 0.03, that's 3%, times 5 years. And guys, that's just an exercise of typing those numbers in the calculator and pressing enter, and you're done with this problem.
Then we put the 0.03 times 5 in that exponent slot.
That's where it is, right?
Oh.
Okay?
I got 3.
Do you have to put it in parentheses on the calculator?
You could actually put 0.03 times 5 up there if you wanted to, that'd be fine.
Oh man, I forgot the E.
That's pretty important.
But the E just throws me off because it's a letter.
It's not a letter, it's a number.
It's a symbol.
A B C D
It's
E.
in italicized.
How much money do you have?
$5,809.17.
Good.
Look at that whole day. There it is. Good. Next problem. Thursday or Friday, we did $1,000 at 4% compounded quarterly for 10 years, and we got our answer to be $1488.86. We're going to compare that amount 5 different times. We're going to do compounded annually, compounded semi-annually, monthly, daily, and continuously. I'm not going to write out the equation every time. Okay? So when you're doing annually or semi-annually or monthly or daily, what's changing?
The time. E. Oh wait, no. It's
Year. I don't know.
The value of N is changing, right? For annually, what is N?
1,
Semi-annually,
2,
monthly,
12, 365.
Daily.
Or 66, 64.
It's 365.
I've heard that some banks, whatever, will actually use like 360. Just to rip you off, that's what banks do.
365.
Continuously,
E.
we use E, okay, there is no N,
Super smart.
okay?
I didn't think there was an N.
So we have A equals P times 1 plus
Oh man.
R over N to the NT power.
That's the wrong equation.
Wait, but I thought it was.
Every time, for the ones that I've underlined in blue, P is 1,000. R is 0.04. And T is 10, right? What changes is the n value, and I'm not going to do the math.
Hmm.
I'm gonna trust that y'all can do the math, and I'm just going to plug them in. So, when n equals 1, when we're talking about annually, we will have $1,480.24. That's less than 1488. 1488 was compounded quarterly. What was n? When we got this amount, n was
1,000. Wait,
Quarterly.
So.
n was 4 quarterly, 4 quarters in a year. Okay? When n is 2, plug all these numbers into this equation here. When n is 2, so twice a year, we make 1485.95. What's happening is n gets bigger.
It increases?
N is 1, 1480. N is 2, 1485. N is 4, 1488. Monthly, n is 12. We will have $1,490.83, which is more than quarterly, which makes sense. It should be. How about a bank that's going to compound our money every day? We're up to $1,491.79. And finally, continuously,
E.
we now have A equals P times e to the RT. P is still 1,000. R is 0.04, and T is 10. And when you plug that in, this is only 365 times. This is continuously, so we're gonna make a lot more money continuously, right? $1,491.82.
So much, my brain hurts.
Made a whopping 3 cents extra, compounded continuously as opposed to 365 compounds a year.
Actually, learning something before we can fly.
Yeah, and the bank won't pay 3% or 4%.
I just need to know how to do it. We can talk about it.
Snap it if you want it. We're moving to the next slide.
1491.
The number e is important. That's the base of an exponential function in many practical applications. Growth, decay. The formula is y equals y naught e to the kt. Y naught is the amount or number present at time 0. K is a constant. When k is positive, you're dealing with growth. When k is negative, you're dealing with decay. This happens in growth of microorganisms, bacteria, or the decay of radioactive material. Y'all have heard of carbon dating? To find out how old a fossil is, how much carbon is left in it. They look for specifically carbon-14, and they know the half-life of carbon-14. And so based on the amount of carbon-14 left in some organism, they can tell you about how old it was.
Do you think we could carbon date?
Yeah.
Data from recent years indicates that the future amounts of carbon dioxide in the atmosphere may grow, according to this table. Amounts are given in parts per million. We're going to make a scatter diagram of this data. Look at the data provided. Go into stat and enter that data. Make sure your calculator's clear. 2nd plus 712, if you haven't already. Enter the data.
with the
Wait, I forgot. How do I do that?
No.
Wait,
Do it.
if we go back to stat and code.
Right now, we just want to look at the scatter plot.
Oh, okay.
I'm not gonna put any numbers on my axes, I'm just gonna kind of sketch what it looks like. Once your data is entered, how do you look at it?
don't know.
I mean, I pressed draft, but there's nothing.
Nothing there.
You go to stat plot.
Yeah, we have to go to stat plot first, so second y equals to get the stat plot. You gotta turn it on, right?
Yeah.
So currently, everything is turned off, so second stat plot. Press enter on one of them, it doesn't matter, and just press enter again to turn it on. Now, how do I see my data?
Graph.
Okay, beautiful, nothing there.
Oh, psych.
I wanna zoom to see my statistics.
Zoom fit.
No, I wanna zoom to see my statistics.
Zoom stat.
Zoom stat. Zoom stat will guarantee that all of your data is on the screen, okay? Here's my graph.
Zoom stat. There's no zooms.
9.
Zoom 9. Okay. We'll answer this question, then we'll wrap up tomorrow. It's gonna take us about 5 minutes to finish tomorrow. Does the carbon dioxide levels appear to grow exponentially?
Yes.
Starts off growing slowly, but then it takes off. This appears to be exponential. Okay. And we'll wrap it up tomorrow, guys.
If you would have invested $1,000 in Bitcoin 10 years ago, it would be worth about